Good morning, students. Today we are going to start some few more questions revision for class 12. The first question, inverse trigonometric function. If sine, question number 1, if sine inverse of 1 by 5 plus cos inverse of x is equals to 1. So this can be written as sine inverse of 1 by 5 plus cos inverse of x is equals to sine inverse of 1. So sine inverse of 1 by 5 plus cos inverse of x, sine 90 is 1. So sine inverse of 1 can be written as pi by 2. Since we know that the value of sine 90 is equals to 1. So sine inverse of 1 by 5 pi by 2 minus cos inverse of x. Sine inverse of 1 by 5 will be equal to sine inverse of x. Since we know the formula that sine inverse x plus cos inverse x is equals to pi by 2. So pi by 2 minus cos inverse x will become sine inverse x. Now both left side and right side there is a one single inverse trigonometric function. We can compare their angle. So therefore we can say that the value of x is equals to 1 by 5 will be our answer. This sign can be taken towards the right. It becomes sine inverse of 1. Sine 90 is 1. So 1 sine inverse of 1 will be 90 pi by 2. So pi by 2 minus cos inverse x by this formula it will become sine inverse of x. And now we can compare their angles. X is equals to value 1 by 5. Now let's come to the question number 2. Prove that tan inverse of 2 by 11. Question number 2 LHS. Tan inverse of 2 by 11 plus tan inverse of 7 by 24. As we know that our formula tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y upon 1 minus xy. So therefore this LHS, in place of x it is 2 by 11, in place of y is 7 by 24. So it becomes tan inverse of 2 by 11 plus 7 by 24 upon 1 minus 2 by 11 into 7 by 24. Okay, now we have to simplify it. That is, this can be tan inverse of 24 into 2 48, 11 into 7 77, 11 into 24, and this after LCM it will take the reciprocal 11 into 24 upon 24 into 11 minus 14. So this and this cancels. So tan inverse of 8 plus 7 15, 7 plus 4 11, 125 and 240, 24 into 11 it will be 264 minus 14, that is tan inverse of 125 upon 250, which becomes tan inverse of 1 upon 2, that is our RHS. Clear? Tan inverse of 2 by 11 plus tan inverse of 7 by 24. Tan inverse of x plus tan inverse of y equals to tan inverse of x plus y upon 1 minus xy, that is the formula. In place of x you substitute 2 by 11, in place of y 7 by 24, and after that take LCM and reciprocal calculations. You will get tan inverse of 1 by 2 RHS. Let's move to the third question. Tan y equals to, it is given sine inverse of 2x upon 1 plus x square. You have to find dy by dx. As in the class 11th we have studied the formula sine 2 theta equals to 2 tan theta upon 1 plus tan square theta. So if we are going to take x equals to tan theta in our equation, then it will become sine 2 theta formula. So let x is equals to tan theta. So which implies that theta will become tan inverse of x. So y equals to sine inverse of 2 tan theta upon 1 plus tan square theta, and which is the formula of sine inverse of sine 2 theta, and by the self-adjusting property it becomes 2 theta, since we know that sine inverse of sine x is equals to x. So it will becomes 2 theta. So y is equals to 2 into theta is our tan inverse of x. Now differentiating with respect to x. Now differentiating with respect to x. So we get dy by dx will be equals to 2 into d by dx of tan inverse of x. And 2 into d by dx of tan inverse of x is 1 upon 1 plus x square. So our final answer is 2 upon 1 plus x square. Okay. So you must by heart all the formulas of class 10th, 11th and 12th, especially trigonometric and algebraic formulas. Sin 2 theta is 2 tan theta upon 1 plus tan square theta. So 2 tan theta upon 1 plus tan square theta, by substituting x equals to tan theta, we get theta equal to tan inverse x. Sin inverse of sin 2 theta, as we know that sin inverse of sin x will be equal to x. So it becomes x के स्थान पे क्या है 2 theta. 2 theta 2 into theta is tan inverse of x. Differentiating with respect to x, dy by dx equal to 2 into d by dx tan inverse x. 2 into d by dx of tan inverse x is 1 upon 1 plus x square. So final answer 2 upon 1 plus x square. Now question number 4. We come to the question number 4. Question number 4 is, if y is equals to x to the power sin x plus sin x to the power cos x. Sin x to the power cos x. We have to find out the value of dy by dx. So these both are function to the power function, function to the power function. We have to take logarithmic differentiation. So y is equals to u plus v. So dy by dx will be equals to du by dx upon plus dv by dx. We will apply this because log m plus n is never equals to log m plus log n. This formula compulsory you have to write down. Here we can't take directly the log, as log m plus n is not equal to log m plus log n. So separately we have to consider u is equals to x to the power sin x. We have taken this value as the u. So taking log both the side, log u equals to log x to the power sin x, which becomes sin x into log x. Because log m to the power n is n log n. Now differentiating with respect to x, 1 by u du by dx. It is a product function, separate. Sin x d by dx of log x will be 1 by x plus log x d by dx of sin x is cos x. So du by dx will be equals to u, I am cross multiplying, sin x upon x plus log x into cos x. Now value of u is our x to the power sin x. So du by dx will be equals to u x to the power sin x upon x plus log x into cos x. This is our equation number suppose 2. Okay. Now let another term v is our, this one v हमारा क्या है, sin x to the power cos x. So sin x to the power cos x. Taking log here also both the sides, log v equals to sin x to the power cos x. Here we take log. So it becomes cos x log sin x. This is a single function and this is a function of a function. Now differentiating with respect to x 1 by v dv by dx equals to cos x log sin x will become upon sin x into d by dx cos x plus log sin x d by dx of cos x minus sin x. So dv by dx will become equals to v into cos x cos by sin x cot x minus sin x into log sin x. So v is our sin x to the power cos x, sin x to the power cos x, so cos x cot x minus sin x log sin x, and this is our equation number 3. So we got the value of du by dx, we got the value of dv by dx, okay, cos x log sin x, cos x log sin x, cot x sin x and log sin x. Now we substitute this both du by dx and dv by dx here in dy by dx. In this equation now we are going to substitute the value of du by dx and dv by dx. So therefore dy by dx will be equals to du by dx is x to the power sin x upon x plus log x into cos x. This is our du by dx value. Now dv by dx is sin x to the power cos x, so cos x cot x minus sin x log sin x. That is our answer. Clear? So never solve this type of problem, function to the power function and addition or subtraction function to the power function by taking log directly. You have to take separately variable, first as u, second as v. If there is a third also take it w, and you have to take logarithm separately of all the functions, and then you have to at last add up the answers. Okay. Now let's come to the question number 5. Find the interval in which the function f of x sin x plus cos x, where x is greater than or equal to 0 and 2 pi equal to pi is strictly increasing or strictly decreasing. The given function is f of x is equals to sin x plus cos x. Fifth question, f dash x is equals to cos x minus sin x. For increasing and decreasing function, we take it 0 here. For increasing and decreasing functions, cos x minus sin x will be equated to 0. Cos x will be equal to sin x, and sin x upon cos x will become equal to 1. That implies that tan x will be equals to 1 and tan x will be equals to tan pi by 4, or tan pi by 4, that is in the first quadrant, it is positive, value positive. Now tan is positive in the third quadrant also. So in the third quadrant we can say that, or it can be tan pi plus pi by 4, that is tan of 5 pi by 4, as we have to take the value from 0 to 2 pi, all the 4 quadrants. That's why third quadrant also tan is positive, tan pi plus pi by 4. So x will be belonging to pi by 4 and 5 pi by 4. Is that so clear? Now our number line. Now we have to, the intervals will be, the intervals on a number line. Intervals on a number line from 0 to 2 pi are as 0 से पाई बाई 4, पाई बाई 4 से 5 पाई बाई 4 and 5 pi by 4 से 2 pi. In these intervals we have to check whether it is positive or whether it is strictly increasing or decreasing. So in the first interval I can say that 0 to pi by 4. Our f dash x, what we having? Cos x minus sin x. Cos x minus sin x. As cos x minus sin x in the interval 0 to pi by 4. 0 to pi by 4 means 45 degree. We can take 0 to 30 degree pi by 6. As pi by 6 is belonging pi by 6 minus sin pi by 6. As pi by 6 belongs to the interval 0 to pi by 4. So cos pi by 6 is our cos 30 degree root 3 by 2. And sin pi by 6 is our 1 by 2. So root 3 minus 1 by 2, 1.73 minus 1 by 2, 0.73 upon 2, which is greater than 0. Okay, so here f dash x is greater than 0, therefore it is strictly increasing. Here the function is strictly increasing. In the same way we can check for pi by 4 to 5 pi by 4. In the interval pi by 4 to 5 pi by 4. Pi by 4 to 5 pi by 4 means 45 to pi by 4, 45 to 25 degree. 225 degree. So here f dash x I am going to check now. Cos pi by 3 minus sin pi by 3. 60 degree. Pi by 4 is 45. I am going to check in this interval 60 degree. So, as pi by 6 is belonging in the interval pi by 4 to 5 pi by 4. So, cos pi by 3 cos 60 degree. Cos 60 degree is 1 by 2 and sin pi by 3 root 3 by 2. In the same way, 1 minus root 3, 1 minus 1.73 by 2, that is equals to minus of 0.73 by 2, which is less than 0. So here we can say that f dash x is less than 0. So in this interval the function is strictly decreasing. Strictly decreasing. Now we comes to the third interval. 5 pi by 4 to 2 pi. 5 pi by 4 to 2 pi. 5 pi by 4 में अपना हो गया 225. We can take 7 pi by 4. Okay. So now f dash x in this interval cos 7 pi by 4 minus sin 7 pi by 4, as 7 pi by 4 belongs to the interval 5 pi by 4 to 2 pi, is it? Now if I am going to solve 7 pi by 4, so 7 pi by 4 can be written as 315 degree, I think so. 45 into 7. Yes, it will be cos 315 degree. 315 minus sin 315. So it will be cos 270 plus 45 minus sin 270 plus 45. So 2 cos 270 plus theta third quadrant, all students take, convert, minus sin 45 it will be, and again in the third quadrant it will be becoming minus cos 40, no, sorry, 270 plus 45 fourth quadrant. Fourth quadrant cos is positive, so sin 45 and sin 270 plus 45 it is negative, it will become plus cos 45. So 1 by root 2 plus 1 by root 2 is equals to root 2, which is again positive greater than 0. So f dash x is here greater than 0. So the function is strictly increasing. The function is strictly increasing. Once again you can listen. F of x sin x plus cos x, f dash x cos x minus sin x. For increasing decreasing function we take the trigonometric function equal to 0, tan x equals to 1, as it is given the interval is from 0 to 2 pi. Interval is given in the question as x is greater than equal to 0 but less than or equals to 2 pi. This was the interval. So tan pi by 4, and tan is positive in the third quadrant, so pi plus pi by 4, tan pi by 4. So pi by 4 and pi by 4 will disjoin, divides our number line into 3 disjoint intervals starting from 0 to pi by 4, because it is 0, 0 to pi by 4, pi by 4 to 5 pi by 4, 5 pi by 4 to 2 pi. इसके रेंज में आने वाली डिग्री वैल्यू को चेक करेंगे f dash x में. So 0 to 45 degree we can check for 30 degree. Pi by 6 we got greater value, that is more than 0 positive value, so f dash x is strictly increasing. Pi by 4 to 5 pi by 4 we can take the value. Pi by 6 45 से बड़ी वैल्यू 60 डिग्री है, sorry pi, as pi by 3 belongs to pi by 4 for 60 degree, and then it comes a negative value, so strictly decreasing. And the 5 pi by 4 to 2 pi we can include 7 pi by 4, 7 pi by 4, 2 pi is 360, 7 pi by 4 is 315 degree. So we have simplified it. So we got again the greater value greater than 0, it is a positive greater than 0, so therefore f dash x is greater than 0, so function is strictly increasing function. Now next comes to the integration e to the power x, last question. Integration e to the power x 1 plus sin x upon 1 plus cos x dx. As we know, sin x is given by 2 sin x by 2 cos x by 2 and 1 plus cos x 2 cos square x by 2. So e to the power x 1 plus 2 sin x by 2 cos x by 2 1 plus cos x 2 cos square x by 2 dx. Now we separate it. E to the 1 by 2 taken out of the integration, e to the power x 1 by cos square x by 2 sec square x by 2 dx. 2 and 2 will be cancelled out, and cos will be cancelled out, sin by cos tan, and e to the power x will be multiplied to tan x by 2 dx. Now sec square x by 2 integration, we know that tan x by 2. So we will take this as the first function, this as the second function. So I is equals to 1 by 2 integration by parts u and v e to the power x integration sec square x by 2 dx minus d by dx of e to the power x integration of sec square x by 2 dx the whole dx, and plus integration e to the power x tan x by 2 dx. 1 by 2 e to the power x tan x by 2 upon coefficient will come to the denominator minus d by dx of e to the power x e to the power x, and this tan x by 2 upon again 1 by 2 coefficient dx plus integration e to the power x tan x by 2 dx. Okay, now comes opening the bracket. 2 and 2 will be here cancelled out. 2 upon 2 e to the power x tan x by 2 minus 2 by 2 integration e to the power x tan x by 2 dx plus integration e to the power x tan x by 2 dx. So this 2 and this 2 cancel. This integration e to power x tan x by 2 minus sign, this positive sign is cancel out, and at last we are left out with our answer e to the power x tan x by 2 is our answer. So few of the questions related to all the chapters or all the concepts related to your half yearly examination syllabus I will be sending you on Saturday through PDF. Go through all the formulas, all concepts, or whatever the problems I will give you, and daily I am sending you the through broadcast channel some of the MCQ questions and some subjective questions. Practice a lot, study well, don't copy, and anyhow you people have to appear for your final examination and try to get good marks in mathematics. Score 100 out of 100. I know that you will do much better as you have done in class 11th very well, लेकिन उससे भी ज़्यादा अच्छा करना है class 12th. You can do very well in mathematics. You can score good marks. Try for that. Go and achieve it. Good marks in mathematics and good percentage. Okay, and best of luck for all your examination. Thank you.